A few words about the Science Gateways Community Institute and what we do in case you're new to us. We are here to facilitate this community coming together and sharing experiences, technology, and practices, and we're doing it funded by NSF in order to offer that at little or no cost to community members. Our resources include online stuff like this webinar and our website, as well as hands-on services that we offer through several of our areas of the Institute. So just briefly, each of the 5 areas, I'll tell you a bit about them. So the incubator is there to provide expertise about topics that are relevant to Science Gateways that you may not be able to find on your campus, or you may not know where to find them in general. This is everything from usability to cybersecurity to sustainability planning, and those same topics are offered as part of a week-long boot camp that is offered a couple of times a year, as well as mini versions that are accompanying other meetings and so forth. So check that out if you're interested in learning more about how to run your gateway effectively. Extended developer support provides hands-on direct custom development support for gateway projects. You just submit a form requesting help and describe your project, and we will, if your project has a good is at the right point for getting some help, we can help you anywhere from 3 months up to a year with quarter-time staff help. The Scientific Software Collaborative has put together a catalog which allows you to search for and also post gateways or software components. So this is a great way to promote what you do, but also find resources such as software components that you could use in your gateway. Community engagement and exchange is what brings you this webinar, as well as our annual conference and also the content on our website. And then finally, workforce development does a number of programs to support the development of career paths for students and young professionals in this field, and that includes a summer coding institute, internships, and also funding to attend conferences and other kinds of workshops. So check us all these out on our website if you have any questions, and you can certainly contact us if you want to know more. One last appeal is a quick favor at the end of this webinar. If you could, I'll be putting this link in the chat section of our Blue Jeans webinar software, and if you could just give us quick feedback about how you like this webinar, and also if there are other topics that you would like to know about. It really does take less than 30 seconds. So with that, I'm going to hand this off to our presenter, Derrick Kearney, who is now at RStudio, works for RStudio, and was formerly part of the Science Gateways Community Institute. We thought that it would be great to hear about the work that he knows about and has done with making gateways and gateway components through the use of RStudio. So I'm going to stop sharing my screen, and he's going to share his.
All right. Can you guys see the screen?
Yep, we can see it now.
Awesome. All right. So hello, my name is Derrick Kearney, and today we'll be talking about building applications and content for your gateway with a specific focus on how to get that done if you're working in the R ecosystem. But it should come to no surprise to you that even if you're working in the R ecosystem, you still have to work within the rest of the world's ecosystem. So today, we'll be talking about how to make that happen. Before we get started, I'd like to thank you for inviting me to talk at your webinar. I'd like to thank the webinar organizers for allowing me to speak to you guys today. And also let you know that slides, links, and examples will be available shortly after the presentation at the link and on the Science Gateways website. All right, so I work for a company named RStudio, and sometimes RStudio is confused for R, the programming language, but they're not the same thing. R is managed by the R Foundation, and RStudio does a lot of stuff to help out the R programming language. So we're involved with building other things. Probably most widely known for the IDE. So a lot of people think RStudio, that's the IDE for the popular IDE for the R language. There's a couple of other things we're known for. We build a lot of open source libraries for the R programming language. And then they also have a suite of professional products that help fund that open source work. And so many of the products have open source offerings as well, but the professional versions have features that are more geared towards enterprise environments. And so my role in the company is helping to build tools for testing these products. But before I joined RStudio, I was working with my friends over at hubzero.org and Science Gateways. And we were helping people to build and deploy applications and content that represented their research. See, back when I first started, R was mainly known in fields where people were doing statistics and analysis. And I encountered it when I was helping people to build applications in things like biology and ecology and economics, and even computational anthropology. So people were using R because it was good for that kind of analysis. It was kind of like a wrapper around a bunch of math libraries, but it was a scripting language. It helped raise our level of thinking. But over time, new technologies have come out. And so we entered what some people may have called the age of the web. Now I know what you're thinking. Spider-Man 1 was pretty good. Spider-Man 2 was better, but 3? Anyway, that's not the kind of web that I'm talking about. I'm talking about Web 2.0, or as some people might want to call it, 1.x, if you're in the camp that says that nothing really changed in the technology. But something did change. You used to be able to do your R analysis and hand over something like a static PDF of that analysis to people, and they would be satisfied. But changes in the technology have brought new opportunities. Now you can give that analysis to them on a web page. And if you can give it to them on a web page, you can even make it interactive. So if they want to know how an analysis has changed with different types of inputs, they can change the inputs themselves and rerun that analysis right from a web page and see the results. And so this is something that can be deployed on something like a science gateway where you can have real impact on others. So today, I'd like to show you guys 3 ways to build reproducible content from the R programming language. We'll be talking about applications, APIs, and articles. We'll be building applications with the Shiny library. We'll talk about how to build APIs for your analysis using the Plumber library. And then we'll slightly touch on how to do things in R Markdown, like build articles, websites, books, blogs, everything else basically. So all of these types of content can be published on a Science Gateway. To help drive our conversation, today we'll be using a fun example called a spirograph. How many people are familiar with a spirograph? Go ahead and raise your hand.
We don't have any way to raise your hand, but
okay.
I'd be surprised if anyone hasn't seen it.
Well, it's been a hit toy for the 3 and over demographic for decades. And apparently, it's the easy way for young artists to make amazing designs. So the way spirographs work is you basically have these little gears, and as the gears fit together, the different size gears fit together, if you stick a pen into one of those holes, you can make these creative designs. So back in 2006, a bunch of Spanish physicists wrote an article on Linux Gazette talking about how to model those spirograph curves with equations. So it was a long article, but here's the kind of the short synopsis of what happened. Turns out that you can model spirographs as a sum of exponentials. If we wanted to model a 3-wheeled system, we could do that by setting our alpha value equal to 1 and our theta value equal to 0 using this equation. The third thing you need to know is that there's only 3 inputs that we need from the user for this equation. In R, we can write a function to model this equation. Our function will accept 3 inputs from the user, representing our 3 n values. We're going to create a vector of 1,000 points. Then we'll solve our sum of equations. And lastly, we'll store the real and imaginary parts of the solution into a data frame and return that back to the user. And those will be the points of our spirograph. All right, so at this point, we have a working model, and most people would stop here. If they wanted to share the model with other people would have to they'd have to get the code, you have to install it on their system, and then run this function from the R prompt, entering the 3 commands and then plotting the output. And if they wanted to run the analysis for another set of inputs, they would have to do the same thing again, run the function with the new inputs, and then plot the analysis by hand. So instead, you could build a web application. Web applications work by sending messages back and forth between the user's web browser and the web server. The web applications are generally, they produce HTML, CSS, and JavaScript, and you can think of them as producing a visually appealing interface to your analysis. The good thing is that with the Shiny library, you don't have to be an expert in web technologies to get something up and running. So the library got most of the features for you. And there are 4 main parts of the Shiny application. The first part is the science code, and we wrote that earlier. Next, you'll define a user interface. Now, when you're defining your user interface, it helps to be familiar with the types of widgets that are available. Shiny is using HTML widgets, and so within your application, if you see HTML widgets out on the web, you can probably include them in your Shiny in your user interface. But you're going to want to include some kind of inputs, some kind of outputs, and then describe a layout for your application. And all of that happens inside of this UI section of the application. Next, there's the server code, and that glues the widgets to the UI, the widgets of the UI to the science code. So within Shiny, they really promote things like reactivity, or being able to respond to user changes, and also brushing, which is linking widgets together. So that if you make a change in one widget, another widget will react or has the ability to react in a certain way. The last bit of code at the end is to control launching the web application. So let me see if I can get in here and show you guys what some web applications look like. I know on last fall, we were building a bunch of these over at Hub Zero, and we ended up using a couple inside of the PERC 2017 workshop. So if we wanted to build an application for our Shiny, if we wanted to build an application for our spirograph analysis, it would probably look something like this. And right from RStudio, we could certainly run that. And you can see inside of this code, we've described how our user interface should look. We have a title. We have a couple of inputs. Those show up on the side here. And then we describe how the output should work. So this is all user interface code. And then down in the bottom, we have our server code, which is running our spirograph function with the inputs that we get from the user, the 3 inputs. So as we change the different inputs, the output changes automatically. So this is an output that you could take directly from from the code and launch this on a science gateway like Hub0. All right, so if you want to know more about getting started with Shiny, here are a couple of websites that I can recommend to you. The first one is the Shiny RStudio website, and that's kind of the home for all of the information about how to build Shiny applications. The second one shows basic startup on how to get started with building Shiny applications. So that's an article that gives details, and I think there's an example of building Shiny applications inside of there. Another popular one is HTML widgets. So HTML widgets are they're general widgets that you can include in a lot of different types of R-based analysis, Shiny applications being one of them. But these are things that like Leaflet, being able to bring in maps using Leaflet, or doing different types of graphing using the D3 JavaScript library. So these are mainly wrapped up JavaScript libraries. And the last one is something called a Shiny dashboard. And so Shiny dashboard, if you have if you want to put together a dashboard, there's a functionality within the Shiny library that will help you with laying out that dashboard properly. All right. So in the last section, we talked a little bit about how to get humans to interact with your program. But now let's focus on some of the non-human parts of running programs. So when we talked about web applications earlier, I briefly mentioned that messages go back and forth between the web browser and your application. And so these messages are how information is exchanged between the two programs. The information that's passed back and forth is primarily for interactively visualizing the data from your program. So your web application may be sending back HTML, CSS, and JavaScript back to a web browser, and then your web browser is going to visualize that. But there's another way that you can also make your analysis available to others, and that's through a web API. So the concept is the same. Programs are still going to be sending messages back and forth, but the messages are more focused on exposing data and performing calculations. So it's meant for talking, mainly meant for talking with other programs. So you may be asking, hey, who's using APIs? And the question that you should be asking is, who isn't using web APIs? If you scan through the web, you'll see that nowadays everyone's using web APIs. The Library of Congress is offering a way to query their information. Star Wars fans have a collection that they've put together, and they're serving data about the different worlds and ships and peoples of the Star Wars series. Different cities have transportation systems that are giving insights into their data, when buses are coming, when trains are coming, that kind of stuff. The federal government has a ton of web APIs that you can explore, that allow you to explore the data that they've collected and calculated. And even NASA is bringing us out of this world data about the heavenly bodies, both near and far. So all the cool kids are doing it. And in R, there's an easy way for you to get in on this action. So with the Plumber library, you can create an API for your code by annotating different functions. So let me first remind you of our faithful function for calculating spirographs up in the corner. So next to each point, for each endpoint, for each function, we're going to, so I guess, we'll create a, as part of our API, I guess one thing I forgot to explain earlier is that when you're building an API, you have control over what different people can query. And so when you're building the API, you can decide what the endpoints are. And the endpoints are kind of like the parts of the language where people can ask you for information and then you can respond with different pieces of information. So for each endpoint or type of request that we want people to be able to make, you get to describe the inputs and outputs of that endpoint. So here we have an endpoint called Spiro /calc, and this endpoint will allow a user to calculate a spirograph using custom N1, N2, and N3 inputs. So we've described our endpoint using some annotations on top of a function. So we said if we get a special type of message called a post request to this location or to this URL, then we should run this function. And we're expecting that that message to have inside of it 3 pieces of data, one for each of our inputs. So after somebody has made a request to that endpoint, we'll perform our calculations, and then we'll send them back the XY values that were calculated from our Spiro function. And this request can be made from any programming language. You could do it from Python, you could do it from Node, you could do it on a Bash command line using the curl program, or you could use some of the libraries, the header library in R. Same thing with, we can create another endpoint that will send us back a picture of a plot. So in this endpoint, we're going to make a GET request, and it will be to the /Spiro /plot URL. And we're going to accept 3 input values, one for each of our N values. And what we'll do is we'll call, when a request is made on this endpoint, we'll call this Spiro function with our 3 input values, but then we're going to plot our those output values and then send that plot back to the user. So this is something that you guys can try today. I put up an example of this API on a web server so that everybody could access it. What the API looks like on the in development So here's a version of that API. It actually has 3 different functions, but very similar to the one I just showed you. And if we were to go into the web server and look at this API, we'd probably get we'd first off start by getting a web page that looks like this. So because APIs aren't really designed to be visually, they aren't visually appealing like a web application, what we'll get instead is just a description of what you can do with the API. So on this page, we can see that we have a couple of endpoints. We have a SpiroCalc endpoint. If we make, and this describes what happens if we make a GET request to it. We could also make a POST request to it. So in this case, if we make a POST request to SpiroCalc, it accepts 3 parameters, and we could try it out right from this web page. We'll try with the parameters 11 minus 7 minus 3. And you'll see that when we send that request to our API, our web API, it returns back with the XY values for our spirograph. And so we could make that same request on the command line. And we can get back the information in computer format as well. So by making an API out of our application, we've actually just opened it up to a number of other people who may want to use that application or use that analysis, but don't want to have to go through maybe a web page in order to use it. So let's see, we could also throw it into a program and use the API. So here we have a little notebook that where we can demonstrate using the API. Let's see here. So what we're going to do here is from the R programming language, we can from the R programming language, we can put together our URL with our parameters for making the request. And then at the end, after we get the data back from the server, we can plot that information. So if we look at our value, our result value here, we see we got our XY points back from the server, and now we can plot the value to see what our spirograph looks like. So there are lots of ways that you can interact with an API, and if you're ever looking to make kind of an application or a way that other people can use portions of your analysis without maybe having to run the whole thing, APIs are a good thing to look at. APIs are also good if you have a large data set that you want to make available to other people, but you don't want to have them download the whole thing. You can create an API that allows people to query into the data set if it's too large for them to download at once. All right. So if you're interested in getting started with web APIs, you can visit the R Plumber website. So they have a lot of documentation there talking about how to build both simple and complicated web APIs. And one thing to watch out for with web APIs is that if you have long-running processes, you may have to come up with a scheme for allowing people to continuously query to see if the process has completed. So if you're running R processes in the background, then you'll need to also, or if you're running processes in the background, you'll also need to have an instance of an R process running. So this is not something that you could put on maybe a static web page like github.io, but you'll need some kind of environment in the background that will help with maintaining separation of processes between different people and that kind of stuff. All right, so I think the last topic that I wanted to touch on today was publishing with the R Markdown library. So R Markdown is kind of a combination between the R programming language and the Markdown language. So it allows you to write reproducible content in Markdown syntax, but it also allows you to incorporate features of R. So if you're familiar with the Markdown syntax, it's pretty easy to put together nice-looking web pages and formatting, and you really get to focus on the text that you're writing as opposed to trying to focus on the presentation layer of things. Within our Markdown, you can embed chunks of code in between the lines of narrative, so you have a native you have a literate programming style going on. If you're familiar with Jupyter Notebooks, it's similar, but I'd say one major difference between Jupyter Notebooks and our Markdown notebooks is that the R Markdown notebooks is in plain text. And so that means that you can truly use your own favorite text editor in order to edit it, and it can also be rendered into a ton of different formats. And so I probably couldn't do justice to all the different output types that are available, but certainly you could do HTML pages, you could do PDFs, Word documents, people have made books. You can also incorporate Shiny applications into your R Markdown code. So this is something that we ended up doing last fall when with the My GeoHub project when we presented at PERC 2017. The tutorial, part of the tutorial was written as R Markdown web page, and then also the tutorial, the part that people were actually filling in was written as an R Markdown notebook. And so they were able to follow along the tutorial as a web page and then make changes to the notebook in order to get it to work properly. So you can see that the link should still be up for that, but I have an example of that as well. So in this case, we were working with some data from that had to do with precipitation in the U.S. in Indiana. So we were exploring these different precipitation values across the state. And so when we went for the exercise, the main purpose of the exercise was to build a dashboard that was kind of like this. And we needed to be able to explain to people, one, how to use the RStudio IDE, how to get started with it on My GeoHub, and then how to make changes to the code. And so you could see that we were able to build a website that looks like this with a nice navigation on the side, and also that told people step by step kind of what they needed to do next, and then also what their output should look like. And so all of this was created through an R Markdown file, and you can look through this file and see that most of the there is a little bit of HTML inside of this file for things that we couldn't, Markdown was not good at setting the exact locations of things, but most of the code is reproducible. There's chunks of R inside of there. You see the narratives intermingled, and then output as well. So, and then the part that people had to manipulate was inside of another notebook. We made it. We used the Flex dashboard output style. So this creates a easy way to create a dashboard from a Markdown file. Our dashboard had 4 of these maps inside of it, and it allowed people to go through the different steps and see to view what was the changes they were making and how it differed from the previous steps changes. So all of this was actually an outcome from another project that we had worked on, where we built a Shiny application. It's called INSIP, Indiana Precipitation Explorer, and that is also available on the MyGeoHub website. So that is that's a dashboard that allows people to explore the content of a bunch of it turned out to be CSV files of data. So as you click on the different cities, you get to it's highlighted. The station data is highlighted over here, and then also at the bottom of the page, you get a chart describing the different precipitation values that were observed over time. So. All right, so there's a ton more different ways you can output data in R Markdown. But a couple of websites that I would recommend if you're interested in learning more about R Markdown is, one, go to the R Markdown website, rmarkdown.rstudio.com. It's kind of the holding place for all of this information. Information on the Flex dashboard that we showed. That is, there's a special website that's dedicated towards Flex dashboards, and similarly, there's one for Shiny dashboards. But there's also this bookdown.org website, and that describes how to write books and build websites inside of or using R Markdown. And then the last thing I'll kind of point you to is this link on parameterized reports. So one thing you could do with our Markdown files is you can parameterize them. So if there's similar to a Shiny application where you have an input that you would like to run an analysis on, you can do something similar with Markdown files where you can say, hey, here's a number of parameters, or here's one parameter, and I'd like you to run this or generate a new Markdown report every so often. So you could say, like, every day in the morning, generate a new a new report and use today's data. So maybe in that case, the day would be the parameter that you're changing every day, or possibly if you're looking at stocks over time, you may want to change the stock ticker value. So I think that's a pretty nice feature that not a lot of people may know about. So if you want to learn more about any of these topics, you have applications. You can use the Shiny library in order to build web applications. If you want to build web APIs, the Plumber library is the thing to look at, and that allows you to gives you a way for other programs to kind of programmatically query the data or analysis that you're doing inside of your code. And then the last part that we talked about today were building articles and just building publishing artifacts using R Markdown. And the great thing about all three of these pieces are they can all be published on a Science Gateway. So if you're really looking to have a program that can have impact that other people can use, you should consider one, making it accessible to other people, and then two, publishing it on the web on a Science Gateway. So, thank you for your time.
Thanks, Derrick. I'll open the floor to folks who might have questions for you. Give them a minute. We have a small enough group that probably if you post a question, I can read it to Derrick, and then if you have further follow-up, you can just unmute yourself and speak up. I had a question, which I'll ask while we're waiting to see if other folks post some questions in chat. I just wasn't clear on what the Flex dashboard was. I thought otherwise I thought everything was very, very clear because I'm not a programmer and I actually could follow along with what you were telling us. But what is the Flex dashboard a tool, or is it a mode of interacting, or?
Yeah, it's kind of like a layout. It's a way of being able to lay out what you would like a Flex dashboards primarily for websites. How you'd like your website laid out, right? So in the case of that's using the Shiny dashboard. Let me get back into it. In the case of the this tutorial, when we were using Flex dashboard, we have an R Markdown. I don't want to call it an application, but it's an R Markdown website basically. Mm-hmm. And when you want to lay out, so let me just show you what the end result looks like first.
So you mean like the columns and the fact that you had like left and right column and so forth? Mm-hmm. Because I noticed it was very nicely, cleanly laid out.
Right. So the ability to say, hey, okay, we have it's almost like we have a table here, and you have these different boxes sitting up on top of each other, and they're kind of laid out in a certain way. If we go back and look inside of the file that we used to generate this, we can see here that just by using Markdown, we were able to create specific rows and columns, right? So we said here, hey, here's a row. Mm-hmm. Right? And so our first row is going to include step 1 and step boxes for step 1 and step 2. Right? So the box, I think the box is delimited by this 3 hash mark. We're basically saying, hey, here's in regular Markdown, that would be an H3 header, but because we're using a Flex dashboard, that turns into a box that we can a box inside of our Flex dashboard.
Okay.
And then down here we have another row we delimit another row inside of our Markdown, and we have two more boxes, one for step 3 and one for step 4. And you can see that down here, where in our second row, we have boxes for step 3 and step 4.
Right.
So
Okay.
this layout considered reactive, right? So when it gets too small, it will just automatically go ahead and change up for you,
Nice.
and you have your boxes. And so I think the painless part of this was that in order to get those kind of features when I was building this, I didn't have to know about I didn't have to know about a lot of JavaScript and CSS in order to make this happen.
Mm-hmm.
I was pretty much, you can see that most of the code inside of this file is focusing on the analysis part, like making sure that my map is put together properly, and then I have these markers working. Very little of this particular file is set for is engaging in CSS, HTML, and JavaScript manipulation. So for an application I think that's very powerful. It allows them to build something that looks good, but does not make them have to spend years catching up with the rest of the computing community who's working on web interfaces.
Right. Right. That's helpful. Thank you.
Yeah.
We have a couple questions that have come in. One from Jack said, how will the new middleware and Hub 0 2.2 better facilitate the inclusion of R-based tools?
Hmm. I'm not sure because I don't work for Hub 0 anymore, and so I'm not really aware of the middleware changes that they're making.
And
But if
I'm
somebody
looking at
from Hub 0 is on the line, then
I'm looking at our list. I don't
they
see any
might be able to.
recognizable names, unfortunately.
Yeah,
Um,
I would stay
but
tuned because uh, web applications were on the roadmap, and so it's, before I left, web applications were on the roadmap, and so I doubt that there would be any kind of regression in being able to support this kind of stuff. Hub 0 was supporting this kind of stuff back last summer, uh, um, and man, I think fall of 2016 we first started rolling this stuff out. So my guess is that if there is if there's any change, it's only for the positive.
great. Well, we can also, Jack, we can maybe ask our Hub 0 friends about that at some point too. Um, the second question is from Chunhan, and he asks, when making APIs, I saw a JSON format for input and output in your example. Do any different formats support, for example, XML, CSV, etc.? I think the
Mm.
question is, does our studios or the API system support
Yeah.
any other difference? Yeah.
So when I set up this particular API, I believe I set it up to be to serve out JSON in most cases, and then also it's serving out a picture in this case. So here's a request, here's a GET request for the Spiro plot endpoint, and if we try this out, 11 -7. So if we execute this, this endpoint is actually returning back a PNG file, right? So you have the opportunity to determine what kind of data comes back from your endpoint. If I switch back over here, inside of this when I put together this particular API, I specified that my endpoints were going to be returning back JSON code. And but in this endpoint, in my Spyro plot, where I wanted to return back a plot to somebody, or a picture of a plot to somebody, I specified that I was going to be returning back a PNG file. And so the plot command, I think it automatically produces a writes to a PNG file, so I was able to return that. You can return back different types of data, and that's all explained in the R Plumber documentation. They tell you the different types of kind of baked-in return types, and then also ways to produce your own serializers. So I believe CSV would be well within the capability of R Plumber to return back.
Cool, thanks. And Chunan says thanks too.
Right.
So I don't see any other questions that have come in. I think folks are welcome to add any other ones. I was curious, one other question I had was, you gave some nice examples of when you might use R, for example, your precipitation example in the spirograph, but as I think I mentioned when we were discussing this webinar topic, that I had originally heard of R as being something that was used for statistical analysis, but are there certain things like where you would say, oh yeah, definitely, if you're doing this kind of thing, you should use R, I'm wondering if there are things that it's particularly well suited for, or maybe also not suited for.
So I would say that whenever statistics is involved, whenever some kind of data analysis, words that are big buzzwords today are things like data science and big data and that kind of thing. Those kinds of things, I would say you should look to do that kind of stuff in R. There's a lot of programming languages out there. There's Python, Perl, Tickle. All of these can probably handle different levels, being able to do things like data analysis. I would say R is one of those at near the top of the list. For ease of being able to handle like your data analysis and your math and calculations and stuff. It's an open source language, and so you don't have to worry about losing capability after years of working with it, moving on to another place. But things that I would probably not do in R, I personally don't do a lot of systems level programming in R. You have to understand R is a scripting language, and so there are a lot of its purpose is to kind of elevate the conversation when we're talking about performing calculations. And so if you're doing a lot of low level stuff, then you probably don't want to use the R programming language for that. Probably want to use something like C or Go or something like that. But with the libraries that are coming out, it's certainly widening the range of things that you can do in R. Probably 10 years ago, if somebody said, "Hey, I wanted to do I wanted to build a web application in R," probably would have said, "Not quite yet." Give it a little bit of time. But now there is that ability to kind of put together a web application, put together an API, publish books using the language.
Yeah, it looked very clean, and it's nice to see that Markdown making it so effortless for the most part. Yeah. Well, thank you so much, Derrick. I really appreciate this. It was really clear for even people like me who don't know this kind of stuff. I think others would say the same. I wanted to just take a moment to let folks know to give us your feedback. There's a link in the chat area that I put for giving us your feedback about this, as well as suggesting other topics that we might want to include. And I wanted to also mention we're having 2 webinars in June, a special edition webinar at the end of June, but our regular webinar will be also technology oriented. It's a text sampler of lessons learned from using Keycloak and GraphQL and gateways. It's featuring 2 of our staff members who worked on projects, gateway projects, using these tools. So in many ways, it's much like what you've just talked about, Derrick, that you've been, doing gateway enhancements using R, and these are using 2 other tools. Keycloak is an authentication tool, and GraphQL has something to do with APIs, and I will leave it.
Querying graphs, I believe.
There you go.
Querying
Thank you.
Data that is stored in graphs. Yeah, I'm excited about that one.
Yeah. So, and we have tech blog posts too that accompany this. So, this is an opportunity to ask questions. And then our late June 27th webinar will be featuring people who've attended the Science Gateways boot camps and what they've learned from it. We have a few provocative questions which we've listed on our website on the webinar page. You can see what kinds of things we'll be talking about, and it's a good way to both decide whether you want to attend the boot camps or also whether you would just like to pick up some cool tips and tools and gosh, I can learn this and I don't even have to attend boot camp. So that's what the goal of that is. So I just wanted to bring that to everyone's attention before we sign off for the afternoon. But thank you all for joining us. And we got in chat, we got some other thank yous, not just from me. So thank you, Derrick, for joining us. I appreciate all the work you put into this and making it so clear, and with demos and stuff too. It was awesome.
Yeah, so thank you for the opportunity.
Yeah, thanks. And we'll see you guys next month.